All right, everyone, we're going to pick up where we left off before Thanksgiving, talking about these absolute value equations. Just a reminder of how I showed you how to solve them prior to Thanksgiving. And we're going to look at when we end up with special cases as well, okay? So we have to watch out for these special cases. They come up every once in a while in all of the math that we do. So I just want to point them out to you today. As a reminder, we're talking about those vertical lines. That means the absolute value of x is equal to 4. We're trying to find all of the values that solve that equation. And we said last week that there are generally two solutions for these absolute value equations. Two solutions. If that value is positive, we'll have two solutions. And in this case, the solutions would be x equals. When I use the software I use, sometimes it's to make worksheets. They'll put them in these brackets. Those are called set brackets. You don't need to use them, but if you see them, that's what that means, that the solutions are the set of the numbers 4 and -4. So two solutions there. If that number was 0, if the absolute value of x was equal to 0, we would have one solution. Sometimes we have no solutions. That's the special cases that we'll talk about in a little bit. So really simple case, we end up with 4 and -4. But as I said prior to vacation, when this thing in here is a little bit more complicated, what we want to do is set up two cases. Case 1 is if this thing, if the insides, the guts of that absolute value is equal to positive 12, we will have a solution. But also, if the guts of that absolute value, that thing inside, if that were equal to -12, we'd also have a solution. So we notice what we do here is we write down this thing without the absolute value symbols twice, once as the positive solution, once as the negative, and then we solve. So we would add 7 to both sides, and our two solutions would be x equals 19. And if I do the same thing here, I would have x equals -5. And I should check those. If x is 19, let's see, 19 minus 7 is absolute value of 12, which is 12. That's good. X is -5. The absolute value of -5 minus 7 is the absolute value of -12, which is also 12. So those are my two solutions. So again, as just to reiterate what we talked about before Thanksgiving, first step needs to be to isolate that absolute value symbol. If there's anything outside of it, get rid of it, move it to the other side of the equation. And then after you've isolated, then you're going to set up your two cases. Okay, so isolate first, set up your two cases. Once the positive value, once the negative value, or the opposite of that value, then you're going to solve. And then fourth step should be to check. So isolate, set up the two cases, solve, and check. Here's an equation that's a little bit longer, so there's a little more to it. One thing I do want to point out to you is, well, actually two things. First of all, order of operations. Do not add these together first, right? The order of operations says to multiply first, and that too is multiplied by the absolute value. So be aware of that. If you see that equation written like this, do not add the 5 plus the 2. Another important thing to keep in mind with absolute values that's different from other equations is you do not want to distribute into an absolute value. Strange things can happen if you do that, particularly if you're distributing a negative number or if there's a minus sign inside. So be careful with that. Don't distribute first. So instead what we'll do is we'll isolate the absolute value by subtracting 5 from both sides. I would have 2 absolute value of 3x minus 2 equals, that's 14. And now I'm going to divide by the 2. So my isolated absolute value is 3x minus, absolute value of 3x minus 2 is equal to 7. Now at this point, I can set up my two cases. 3x minus 2 is equal to 7. And 3x minus 2 is equal to -7. And then I solve. So I'll add the 2 to both sides. 3x equals 9. So x will equal 3. For the other equation, I'll add 2 to both sides. 3x equals negative 5. Divide by the 3. So I don't have a nice neat number here. I do get a fraction, but that's okay. X equals negative 5/3. And again, I should check these. Just as a reminder, let me double check these solutions back in the original equation. So if x were 3, and I substituted 3 in for x, I would get 5 plus 2 times the absolute value of 3 times 3 is 9 minus 2. That should equal 19. So I put a little question mark over that equal sign just to remind myself I'm just checking here. That's 5 plus 2 times the absolute value of 7 should equal 19. And order of operations would say take the absolute value, that's 2 times 7, plus the 5, which is 14 plus 5 is 19. So I know that x equals 3 is one of my correct solutions. Now I want to check that negative 5/3. Just to remind you, fractions are not as scary as you think they are. So let me check that negative 5/3. I'll put negative 5/3 in for x back in the original equation. That says 5 plus 2 times the absolute value of, all right, it's 3 times negative 5/3. Well, that's not that scary because that 3 and that 3 cancel each other out, right? That's negative 5 divided by 3 times 3, which is just negative 5 minus 2. And again, that should equal 19. Let's follow through here. That's 5 plus 2 times the absolute value of negative 5 minus 2 is negative 7. Well, that's 5 plus 2 times absolute value of 7 is 7. 2 times 7 is 14, plus that 5 gives me that 19. So there are my two correct solutions. So isolate, set up your two cases, solve, and check. Here's another quick case. It's not isolated yet. I'll divide by that 3. I get x, absolute value of x plus 9 is equal to negative 5. Set up my two cases. X plus 9 equals negative 5. X plus 9 equals 5. So those two cases are the positive and the negative of whatever that isolated absolute value is equal to. I'll subtract the 9. And x should equal negative 14. Subtract the 9, and x should equal negative 4. So two nice solutions. Again, I'm going to check them back in the original equation. So my original equation was that 3 absolute value of x plus 9 equals negative 15. If I do 3 times the absolute value of negative 14 plus 9, do I get negative 15? Well, let's see. That's 3 times the absolute value of negative 5. But the absolute value of negative 5 is positive 5. And when I do 3 times 5, I do not get negative 15. Negative 14 is not a solution to this equation. Let me check that negative 4. If x is negative 4, I would do 3 times the absolute value of negative 4 plus 9 should equal negative 15 if this is a solution. That's 3 times the absolute value of 5. But the absolute value of 5, again, is positive 5. That gives me 3 times 5, which is not negative 15. This is not a solution either. So let's break down this problem and figure out at what step we realize this is not, does not have a solution. We did all of the steps correctly here, including that last step of checking. And this is why I tell you to check as the last step, because there are sometimes we can come up with perfectly nice solutions that are not, they look like solutions, they're not actually solutions to the equation. They are solutions to 3 times x plus 9 will equal negative 15, but they're not solutions to this. So we have to be careful to check. And let's break this down though and figure out why this had no solutions. This is our special case alert here, okay? There's a particular type of these absolute value problems that have no solution. And we want to, if we notice them, we don't even have to do the problem. We're good to go. But here's why this happened. Our original equation was 3 times the absolute value of x plus 9 is equal to negative 15. So to isolate that absolute value, we divided by that 3. We get the absolute value of x plus 9 is equal to negative 5. And it's right there, if our heads are in the game, if we notice right there that we have an absolute value equation that's equal to a negative number. The absolute value of this thing can never equal negative 5. As soon as we recognize that, with the isolated absolute value, we can make the call that there is no solution to this equation. If you notice that, great, you can stop right there. Isolated absolute value is equal to a negative. Stop, there's no solution. If you don't notice it though, don't skip that check step, because that very last step at the check, when we realize neither of the solutions worked, that's when we can also say there is no solution. So either way, I don't care which one you do. If you notice it, great, you can say no solution. If you don't, make sure you're checking all of your solutions. And just be careful with these special cases. Don't make the call on no solution or one solution or two solutions until you've isolated the absolute value. Right now, this looks like it's equal to positive 4. So maybe there's solutions to this equation. However, we can't make that call until we've divided both sides by that negative 2. Now we have absolute value of x plus 3 equals negative 2. And now, at this point, once it's isolated, we can make the call that there will be no solution to this equation. So again, don't make that call until you've isolated it, moved everything that's outside the absolute value away from the absolute value. And just to recap, I want to show you how we write this algebraically. What we say is the absolute value of x equals a, so an isolated absolute value is equal to a number, has two solutions, and we'll know it'll have two solutions if that isolated absolute value, if that a is, we write it a is greater than 0. So if that number is positive, we're going to have two solutions. If we'll end up with one solution if that a, that number is equal to 0, and we'll end up with no solutions if that a value is less than 0. So algebraically, that's what that looks like. So I think we're about done for today. I'm just going to have you do some practice problems, and we're going to start thinking about absolute value inequalities tomorrow, which are a little more complicated. All right, that's it. So go check on Schoology what your homework is. All right, bye-bye.